morning, ladies and gentlemen. About to welcome again to room 15, where? Learning errors. Thank you for bearing witness to that true principle of eternity, learning never ends. And so we're here starting on simplifying given expression. I think yesterday we got through 6, didn't we? You have the paper, Nate? Dustin, you got your paper? Everybody else? Okay, good. All right. Okay, so, yes.
I lost my paper.
Lost your paper, okay. So that's an issue. Okay, so basically it's simplify the expression and find excluded values. So that's one thing we have to be concerned with. So we're gonna keep that going. So we look at number 7. What's our first thing? What are we going to do with this one? What are we going to do with this one? Carly, you got to tell us what we're going to do with this, or else I'm going to have to go ahead and make you take the AP test. I'm kind of giving Carly a hard time. What should we do with this? Okay, find the zeros and factor. Okay. Yeah, denominator, right? Yeah, good deal. So Carly is not demonstrating excellence today in AP testing, is she? But is she demonstrating excellence in this class today? Yes, she is. Right. So Carly is here to bear witness to learning never ends. Appreciate that. So what we're going to do is we're going to take this 3x squared plus 4x plus 1 is not equal to 0. So I give Carly a hard time, and what does she do? She shows what she's really made of, right? Isn't that really awesome work? So how can we factor this guy right here? Any ideas on that? How are we going to factor that? Somebody help me out with Preston or somebody. Oh, so you factored it already? Yeah, so Carly is really. How'd you find that? Let's see the factor. Okay, so now she's putting the factors. Or you just do it in your head? Oh, okay, I'm right for you. Yeah, so she has it right. She wasn't doing exactly the way I did, but anyway. I don't know exactly how she did, like she's just, maybe, she found the zeros. So what she did is she put as her excluded values, x cannot equal, did you say, -1? And x cannot equal -1/3. And so she had this written down, and I didn't really see her showing work for it. So what we did is you can factor this a number of different ways. One of which is, that looked like the way she was doing it, is you can take this, and that's going to be 3x here, and x. You can have plus plus. And what are your factors of 1 going to be? 1 and 1, right? So here's our factored form of this. So we can rewrite this as, in the denominator, we have 3x plus 1, and then x plus 1. So that's our denominator in factored form. And in the first period, we used a box method for this, is how we did it in the first period. Like this. Because if you go like this, you can put your 3x squared here and 1, and you know that's going to be 1 and 1. This is going to be 2x and 3x. Now, possibly it could have been 6x. It could have been, no, it's going to be x. I put 2x and 3x along with it. Just x and 3x, right? So those are your only possibilities. So here you get your 3x and your x. So that's where your 4x comes from. So you're only going to be able to simplify if you can also factor that top one and cross something out. So what's going to be your factored form of your numerator here? Well, the only way you're going to have, what do you have to simplify? One of these factors is going to have to be the same as the one down here, right? So let's try that. Let's try 3x plus 1. If we try 3x plus 1, what is our other factor here going to have to be? Well, it has to be 2x plus 1, right? And why do we know that? Well, the reason we know that is because to get 6x squared, you have to multiply by 2x, right? And then over here, to get 1, you have to multiply 1 by 1. So this is factored form. So what do you have left? You have this, right? You have 2x plus 1 over x plus 1. And so this is going to be your answer, and also with your excluded values up here. Okay? Okay, so now I want you to do number 8. And then we're going to, and then there's also an X method where you do this, where you have this AC up here. We'll factor that. You have AC, which is 6, and down here you put 5. And this will be 2, 3. And you get divide by A, and A is going to be 6. So here you get 1/2. Here you get 1/3. And then once after you bottoms up to this guy, that's how you get this on top here. So that's that. Okay. What are you going to do for number 8? So this morning, Shady looks like she's in a blood donating mood. Are you in a blood donating I don't think there's a blood drive going on today, but she's here to help people. You're here to help people today, aren't you, Shaylee? To save lives. I really appreciate that. You can do a lot to help people, can't you? When you think about it. Okay, what'd you get for number 8? Anybody? What did you do on number 8? Anybody? What are you going to do for number 8?
Right now, I'm putting my
Put in your box. So which one are you factoring, the top or the bottom? Top, right. Is the bottom factorable? No, it's not. Okay, because when you got x squared plus something, that's not factorable. In fact, how many excluded values do we have here? Do we have any excluded values? We do not. Okay, we explained this. We went through this in the first period today already. But if you set your denominator x squared plus 1 not equal to 0, and you solve for this, you have x squared is not equal to negative 1. So if you solve that, you get x is not equal to plus or minus square root of negative 1. What's the square root of negative 1? What's our square root of negative 1 defined as? Well, what it is, it's Tyler, remember this one. What it is, it's square root of negative 1 is defined as the imaginary number, what? I. So that means, what this means is that there's no real number. So this is no excluded values. No excluded values, and help me be able to spell it, excluded. Yet, can this thing still be simplified? I don't know. What's your factored form of what's on top here? What's your factored form of x to the 4th minus 1? What's your square root of x to the 4th? X squared, right? So x squared, and then we have plus minus. And what's our square root of 1? 1. So now can we make any simplifications? Can we make any simplifications? Yes, how do we make simplifications here? We just cancel right out. So what do we have left as our answer? So this is going to be our simplification. And also no excluded values, okay? So this is factoring, but another technique besides what we did up here, Carly did. Number 7. So we're doing with number 9, 10. I think we're going to try to finish 9 and 10 today. Okay, add or subtract given expression, simplifying each result and noting the combined excluded values. I want you to look at number 9. No, I'll tell you why. Is psychologically, I'm ready for a lot of what Summer has, but not for all of it. And I'll tell you why. Is I have on July 13th, going down to a math teachers conference in San Antonio. I have to make a presentation. And so I have getting ready for that. And that's a lot of work. In addition to that, what I have is, I'm teaching up here in room 15 the Monday after school's out, which would be the 23rd. I'm doing a district professional development session. So if you're like Preston, if your mom wants to come and get my professional development seminar, she can come in and sign in to be here this day. She can see some of the things we do, some of which are mathematics, but a lot of my systems for this class are not mathematics, right? There are other things I do in class that are not strictly related to mathematics. So yes, who else has a parent who works for the district? Anybody else here? So your mom can come. She has to sign up for it, and then she can come for professional development. She gets her professional development hours. And so that's what I'm doing. And it's going to be, and so I have to get ready for that. So there are things I have to get ready for. But it's going to be okay. I know what I need to say. I just have work to do. It'll be good. It'll be good. It'll be good. And we're going to be singing in our professional development like we do in class. So for people who come, like your mom, you can tell your mom about it, is people have a good time at it, I hope, learn something. Maybe I'll have something worthwhile for it. Probably. I hope so. That's the idea. So anyway, that's it. And then I've got like, I have in June, early June, my mom's being buried out in California, so we're going out there for that. And then and then late June I have a church girls camp I'm volunteering at in Oklahoma, so I'm going up there for that. And then I just found out yesterday that Jose, who is with he's a member of the New Harvest Baptist Church, you know what I'm talking about? He's going to be giving a sermon on July 31st, I think it is. So I plan to go to that church on that day and see his sermon. So I plan to do that. So I got things kind of spaced out, so it'll be good. And I don't know if I'm going to be able to go anywhere else. I have a friend up in Oregon who's very sick, who may not live too long. I might try to visit him if I can. So that's it. Hope you guys have good summers planned. It'll be great summer. And then when I go down to that seminar down in San Antonio, I stay there for a few days. Mrs. Calkins and I are going down there to learn and so forth. And I'm going to see other things from other teachers, educators, professionals. Okay, what'd you do? What are you going to do for number 9? Add or subtract the given expression, supplying each field noted and combining excluded values. So what does it tell you to do?
Add or subtract.
Yeah, it does. What else does it tell you to look for and find? The what?
Excluded values.
Find the excluded values. So what are the excluded values of this going to be? What can X not equal? Okay, X cannot equal -1, I'll accept that. What else can X not equal? X cannot equal 0. Who said 0? Somebody back there said, right? Good job. So X cannot equal -1. You see why X can equal neither one of those things? Okay, what are you going to find next to be able to add these together? What do you need? You need something to be able to do that. You need something, 2 words. 2 words, a 2-word thing you need to be able to add these together is what? A what? A common denominator. Okay, so common denominator, so Seth has been coming today, ready to contribute. Right, Seth? Logan, are you okay, Logan?
Yeah,
I haven't heard much from you today. You're usually one with something to say. Yes, we have a common denominator, okay? And you can always get your common denominator by multiplying the denominators together. You always have it. There's also a thing, something called a least common denominator, which is that maybe you don't need quite everything multiplied together because sometimes those common denominators have something in common already. But we're going to get into that later. So now we're going to rewrite this to common denominatorize it. So we have 1 over 1 plus x. And what do we have to do now to get our common denominator here? We have to do what? What do we have to multiply by? We have to multiply by x, right? So we multiply by x. What else do we have to do? We have to actually multiply the top by the same thing, right? And then, so now we have plus, and we have plus, it's going to be 1 minus x, and down here we have x. So what do we need to do to common denominatorize this second fraction? What do you have to multiply by here?
The same thing, or the other side?
You have to multiply it by 1 plus x. So now we have our common denominator, don't we? And what do we have to multiply the top by? 1 plus x.
Yeah.
Okay? So now what we have is we have x plus 1 minus x, 1 plus x, and that's all going to be over this thing here, right? I'll put an x, 1 plus x. Okay, what are you going to do next? What do you do next? Cross, who said cross out stuff? Who said that? Okay. Can you cross this out? No, you can't do that because when if you cross this out, there's nothing to cross this out. So to be cross-outable, you have to have the same thing up here. You have to cross out something here and here because of that. So it's not cross-outable. That's a new word I just made up. Isn't that a weird word? Cross-outable. Man, making up new words. We had common denominatorize, now cross-outable. Wow. Okay, so what are we going to have to do here? What are we going to do? Since we can't cross it out, what are we going to do? Come on, what do we have to do? What are we going to do next? Should I just fall asleep, wake me up and tell me what to do? All right. Should I just snore? Well, what are we going to do? Yeah, but to force simplify, we have to do what? We got to go ahead and multiply all this together, and then we'll be able to do that. So let's go and multiply all that together. So we have this 1 minus x, 1 plus x. So 1 minus x, negative x squared. So what we have here is negative x squared, and those will cancel out, plus 1. And so we have left here is, so that's going to be replaced by negative x squared plus 1. So we have negative x squared plus x plus 1. And that's all going to be over x, 1 plus x. And then another thing you can do, we haven't done it, we can do it right now. is we can take that 1 plus x and write that in more of a standard form like this, right? And so we have, right now, we have our simplified fraction, we have our excluded values, okay? Okay, erase this. So I want you to do number 10. We'll go over that in just a little bit. So who was the one who helped me with this? I know Luke did, Seth, who else helped me with this one? Was it mainly Luke and Seth? So I don't know if you know this, but Luke makes all these cute drawings on here. Now, coincidentally, I have another student in pre-calculus, another Luke, who likes to make drawings on his papers. So Logan, can you do something on this one?
I'm trying, I just don't understand.
Okay.
Not watch like the last time.
Yeah, because Logan is usually quite a contributor to these things. All right, what are you gonna do with number 10? Dustin, what do you think? What are you gonna do with number 10? Zach, what are you doing with number 10? Oh, man, that's terrible. That's terrible. TV, what are we doing with number 10, TV? Whoa, man, that's sit and get, you're not part of the, you need to be part of the brain engaging, interactive learning process. That goes beyond sit and get, right?
I haven't seen anybody work.
So Luke was trying to work, Seth looks like he's working. Carly looks like she's working on
I'm
this.
just like that with it.
Nate, what are you gonna do on this, Nate?
We got like a week to come
Right,
back.
Gio, what are we doing on this, Gio?
Let's just let learning start to die down.
Start learning, start to die down.
Learning does it in here.
Dustin, Dustin, you have an idea? So you have good ideas a lot of the time. What are you gonna do? He doesn't recognize it. What about you? What do you think?
Me?
Yeah, what are you gonna do?
Definitely not.
Rowdy, what are we gonna do on this one?
Probably just look over with that.
You find the square,
Find the what? Find the zeros where? What?
denominator?
Denominator, right? Set our denominator not equal to 0. Do that, right? Okay, let's do that. I knew there was some form of intelligent life back there in your brain someplace, right? Let's go ahead and look at this. So we take our x squared minus 4 not equal to 0. So what do we have here? We have x squared is not equal to 4, right? So what is x not equal to?
-4.
No. Take the square root of both sides here. X cannot equal what? Yeah, so x cannot equal plus or minus 2. So these are the excluded values, okay? Excluded values. Okay, this is the first, when you look at this, that's the first thing you should see, okay? That's going to be easy to figure out. Let's set that not equal to 0, figure out excluded values. Okay, what next? Do we have a common denominator already here? Yeah, we do. So we can just take our, so we got our x squared minus 4 down here. And up here, what do we have? Well, we have x, and we have plus 4, and we have minus 2x, and minus 2. And then if we go ahead and combine everything up here, what do we have? We have negative x plus 2. And down here, what's our factored form of x squared minus 4? It's x
-2, x -2.
x plus 2x minus 2. And can we cancel out stuff here?
Yes.
Not quite, right. We have to do something else, right? So let's go ahead and make this negative x minus 2. And now doing that, we have our x plus 2, x minus 2. So what can we cancel out now? X minus 2. Let me go ahead and write that down here. So we cancel out this, right? So what do we have left?
X plus
No, we have negative 1 over x plus 2. So this right here, this is going to be our answer, and with our excluded values. And we're just going to have to leave it there today, because we have, I think, 11 and 12 tomorrow. But I want you to come tomorrow ready to talk about excluded values, because the brain was not engaged as much as it needed to be for most of you today. Seriously. Can your brain be better engaged tomorrow? Can you do that? I mean, this class was not a total dumpster fire today, except for people getting on their phones now. Please, help you on your phone.